So now a bit of an update on progress with repairing these machines. I've been mainly working on this particular motherboard, and the reason for that is I did some testing on it and I found some things that were not right. And obviously that's a great thing to pursue because you know you're improving something, and if you eventually fix all the problems then it will work. So I've been working on this and I found that this chip here was completely dead, so I've replaced that. Previously I'd put these little short pieces of wire here because the traces in that area were completely destroyed. I was able to look at the schematic, work out what needed to be connected to what, and recreate those connections with the wires there. And I've also been working on this orange component here. It looks like a chip, but actually it's just a series of resistors in a chip-shaped package. And because it's next to the battery, it's extremely vulnerable. The bad news is that this is part of the data bus for the machine, so it's really critical. And if there's any breakage in that area, the machine basically won't work at all. If we zoom in, and I'll zoom in on the one a little bit further along, you can see that the legs of the chip are connected, or at least some of them are connected to a trace, which then is connected to a little hole. Those holes are called vias, and basically what they are is a passageway that links the various layers of the circuit board. So it goes vertically down and it allows the signal to change from the top layer to one of the middle layers, go somewhere else and pop up somewhere else on the board. And you can see that that's very thin. I reckon the trace is probably about 1/2 mil, maybe 1/4 mil wide. It's very narrow and it's just a thin layer of copper. When the battery leaks, the alkaline that comes out of it eats away at the copper, and you can end up losing everything. You know, that the ring may disappear, or that thin connection there may be eaten away completely. Another thing that can happen is most of the metal is left behind, but you actually get a crack between the ring and the straight part. So it looks okay, but it might not be connected anymore, and you have to use a multimeter to check that, see if it's connected. If the connection's lost or the material's just been eaten away, then what you have to do is a really fiddly repair. And I should explain that the vias, although they are originally holes, they're actually filled with this green paint. It's like a solder resist paint that's sprayed onto the board. That fills up the holes so they become effectively blocked. And then when the battery leaks, all the alkaline and the corroded corrosion products gather in the hole, so you get a hole full of this horrible debris basically. So what you need to do is clean all that out, and the way to do it is with a PCB drill like this, very fine. I think this is a 0.3 mil. It's got markings on it, but they don't actually tell you what the diameter is. And you basically get that into the hole like that, and just turn it by hand, rotate it like that, and that clears out all the paint and gunk that's got in the hole. Eventually brings you back to bare metal. And then when you've created that bare metal surface, you get a very, very fine wire, push it through from the other side and solder it in position. And then the tip of the wire is only about 2 millimeters long. You can bend it over and solder it onto one of these legs. So you then recreate the connection that was lost. And I've been doing that down on this other component. Looks a bit messy. That's because I'm learning how to do it, and I've not quite finished. I need to do some more modifications. You can probably just about see here where I've brought those wires up from underneath and bent them across. This one needs resoldering, it's not gone well. In the process of doing this, I found that more and more connections were broken, and I also discovered that a lot of these, well, half of the vias are underneath the actual component itself. So I had to remove the whole thing, make the repairs underneath, and then try to put the component back on top, which is as difficult as it sounds because it's designed to sit flat on the motherboard, and with all these lumps and bumps of wires underneath it, it doesn't really do that anymore. So getting it to stick back down is hard, but we are making progress. I've got to the point now where the machine will run a self-test when it powers up, and it flashes the floppy disk light at you to tell you which bits of it are not working. And you can look that up from a chart that's available online. So it's enabling me to narrow down what the issues are, and hopefully it will lead me to completely fix this board in the end.